This is the ACT from December of 2017, form A10. This test was printed in the ACT guide. I believe it was the 2019 and 2020 guide. I forget the year, but it was featured as practice test 5. We're going to go down to the science section, because the science section tends to be one of the more misinterpreted sections on the ACT, because it's a very odd section. It's very different from any section that you're going to see in other tests. So I think it's important to know how to navigate a test like this. Now, at first glance, it might seem like you would need to know some very obscure science to do well on this test. This particular passage is about Earth's gravitational field. And so at first glance, you might think that you would need to be an expert in gravitational fields, but the ACT has a point that you don't actually need to be an expert in any of the science topics to do well on this test. Instead, they say that all you need is the information in front of you and some very basic science knowledge. Basic as in saying mass is neither created nor destroyed. Gravity is dictated by mass. And so the more massive the planet, the greater the gravity. Ideas like that. But most of the time, all you need are the charts and descriptions in the passage. Instead of science being tested, the ACT science section is actually testing you on logic. So we're actually going to use logic to answer all of these questions. So we're going to go over these questions one by one. We're not going to read the passage beforehand because the questions themselves actually give us enough clues to figure out where to look. So let's go ahead and look at 14. Right? What are these clues that we're looking for? Well, in 14, the first question tells us to look at figure 1. So we're going to go ahead and mark figure 1. Let's get our marking tool here. And we see that it has figure 1 listed there. So we look at figure 1, we see figure 1 is written right here. It's asking which two regions are most similar in thickness. Now, it's important here that we don't assume what causes thickness, right? Like, my initial assumption is that thickness is caused by the gap between the solid line and the dotted line. But we don't want to make any of those assumptions right away. Instead, I want to use an answer choice to help guide how the ACT wants us to look and think about this chart. So the first answer choice says the inner core and the outer core. Let's just find where those things are. Well, inner core and outer core are listed up here. So they're labeling sections. In this case, the inner core is this white section, and the shaded area here is the outer core. So now what are we looking at, right? Well, in order to understand what thickness could be, we need to look at the axes of the chart. The axes, believe it or not, are the most important part of a chart. The tendency is to look at the lines inside the chart and make assumptions about them. And indeed that the graphics in the chart are probably more eye-popping than the words and the numbers on the outside. But we have to understand that the graphics only have meaning because of the symbols and numbers on the outside of the chart. So we really need to look at those things first. Now, if we look at the outside, on the left, we see this P-looking figure. We don't actually need to know what it exactly is right now. We could just call it P. In actuality, this is the Greek letter rho, but we'll just call it P. In parentheses, we see that it's G/CM3. Okay? We actually don't even need to know that G stands for grams and that CM stands for centimeters. We can just think of this, that P is measured in G/CM3. Okay, so we're going to have just that very rudimentary understanding of the left side of the chart. Okay. On the right side of the chart, we see GE, and in parentheses, capital N / kg. Now on the bottom, we see the variable R, and then we see km. Now, if we do need any clues to what these things mean, we can always look at the paragraph up here. Now, without looking at the paragraph, I do have enough background information in science to know that km is kilometers. And kilometers is indeed a distance. So my gut tells me that R is going to be describing thickness. But we can go ahead and double check what R is. So we see R is right here, and it says matter within Earth are graphed versus distance R from the Earth's center. So R represents the distance from the Earth's center. So the inner core apparently is represented by the interval between the Earth's core, that is 0 kilometers from the Earth's core, to 1,000 kilometers from the Earth's core. So that seems to be a thickness. The inner core seems to be 1,000 kilometers. Whereas the outer core goes from a little more than 1,000 to halfway about 3,000. So say about 2,500. Okay. Are they the most similar in thickness? Well, we won't know. We'll have to compare them to other comparisons that the ACT is suggesting. So we're not going to do anything with F, but it looks like we have a pretty strong sense of what thickness is. Let's go ahead and look at letter G, the inner core and the upper mantle / crust. Well, the inner core is, as we said, right here. The upper mantle / crust is right here. And these two sections seem to be a bit more similar than the inner core, outer core. The inner core and upper mantle crust seem to be close to around 1 box wide. Inner core is a little bit wider. So if I had to choose between F and G, I would definitely lean toward G. So we're going to go ahead and cross out F, because the existence of G disqualifies F. So let's look at H. We're comparing the outer core and the lower mantle. Well, the outer core is right here, and the lower mantle is here. Now this, oopsie, let's go ahead and, well, why not? Let's go ahead and just move the circle as opposed to circling it. Let's delete that. Now, if we look at the outer core and lower mantle, these two look really similar. They're both approximately 2.5 boxes wide. Whereas the inner core is definitely bigger than a box, and the upper mantle crust is definitely smaller than a box. We can tell that because we see that where it's cut, it seems like both pieces are less than half of a box. So if I had to choose between G and H, I would probably elect toward H. So I'm going to go ahead and I'm going to eliminate G. We'll check the last answer. Now comparing the outer core and the upper mantle crust. So we have the outer core, but the upper mantle crust is right here. Clearly, the outer core is way thicker than the upper mantle crust. So we're going to eliminate J. My final answer would be H. Okay. So let's go ahead and continue. Question 15. According to figure 2. All right. So figure 2 we see is down here. The innermost 30% of Earth's mass. Okay, well, where would the innermost mass be? Well, again, we need to examine axes. We see the percentage of Earth's mass. Okay, we did see 30%. Here's that R again. And it's safe to assume that if the ACT is using the same unit here as we saw up from figure 1, that they probably represent the same thing, right? Again, if you want to look at the paragraph above it, we can skim and look for the letter R, and it says R is a distance from the Earth's center. So it means the exact same thing. So the innermost 30% of Earth's mass is going to be right here. Here's 30%. Is located between R equals 0 km end, and we have these 4 different values. So what I suggest when you have a chart is I suggest drawing directly onto the chart. Okay? So you notice how we're going to draw a line directly down, or we're going to draw a line directly across. And then once we hit the graph, we're going to draw a line directly down. And we see that we get a number between 3,000 and 4,000. So let's just say 3,500. If you look at the answer choices, there really is only one answer that's close to 3,500, and that's 3,400. So that's question 15. Let's go into question 16. Right. Figures 1 and 2 indicate that the Earth's radius is approximately. All right, so here's another question involving radius. Well, how big do we expect the radius of the Earth to be? Well, let's take a look at figure 1. If we look at the tops of the chart, we see inner core, outer core, lower mantle, upper mantle crust, and we see atmosphere space. Well, which of these layers would include the radius? That is, which layers would the radius go through? Well, we would expect the radius to go through all the solid matter. And so crust, mantle, core, this is solid matter. But we wouldn't expect the radius to go through the atmosphere. And so if we look at that amount, we see it's about between 6,000 and 7,000. So my guess would be a number between there. And it looks like most likely answer there would be J. So I just immediately circle that. You don't really need to look at figure 2. But if you wanted to look at figure 2, we could see that the limit of figure 2 only goes up to about 6,500. And we see that the Earth's mass goes to 100% at 6,500. So we expect the entire Earth to be within 6,500 kilometers of the Earth's core. Okay? So notice we have 3 questions. We didn't really understand much at the beginning of the passage, yet we were able to answer these questions fairly easily. Let's go on to 17. Based on figure 1, the approximate value of Earth's gravitational field at R equals 14,000 is most likely. So we go back to figure 1. We need to find R equals 14,000. Now, R is on the bottom. 14,000 is off the chart. Okay? So we want to make a mark approximately where we would expect 14,000 to be. Can't draw 14 here. It's where this red mark is. Okay? So at 14,000, what do we expect outside of the chart? Well, there's a standing rule that any patterns that are established in the chart are probably going to continue outside of the chart. So if we look at this dotted line and we extended it, right? We see that it is decreasing, but it's decreasing at a lower rate, and it seems to want to get closer to 2. Okay, we don't expect to deviate too much from 2. So if we drew another line up to about 14,000 through here, we would expect a point around 2. And there's really only one range that fits, and that would be C, because 2 is directly between 1.5 and 2.5. We definitely wouldn't expect 2.5. Again, because we are getting lower, and the dotted line is already at around 2.5 at 13,000. And we definitely wouldn't expect below 1.5 because we are decreasing at a lower rate. We expected this line to level off. Okay, so the answer here is 17C. Okay. Now to question 18. On average, the Earth's crust is about 30 kilometers thick. Okay, 30 kilometers thick. Based on figure 2. We're going back to figure 2 here. The Earth accounts for approximately what percent of the Earth's mass? Well, the Earth's crust is the farthest away from the center. Again, we verified that up here. 30 kilometers would consist of this edge right here, but it wouldn't be very much because you see that the axes are in the thousands. So we wouldn't expect very much space for the crust. So we'd expect kind of like this tiny little piece up here. Not very big. Almost 0. Are there any answers that are close to 0? Yeah. 1%. So I would select 18F here. No other answer seems reasonable. Because these bigger numbers, in order to achieve them, we would need to have a much bigger distance here. Okay? So the answer for 18 is F. 19. Now this is a longer question, and it could be very easy to be intimidated by this question. We have to understand, though, that longer questions give us actually more opportunity to eliminate information. I actually look forward to the fact that we have longer answers. One thing that can make your life a lot easier is know that answer choices often on their own have to be true. So even if we don't understand or know what question is being asked, if the choice is not factually true, then it's probably wrong. Okay, so check this out. We are going to attempt 19 without even reading the question. Let's look at answer choice A. So this choice A says, the rock located at R equals 2000 km, the value of GE is less at that location, so the rock has a smaller gravitational force exerted on it. Okay. Again, we don't know the question, but it is stating that the value of GE. So let's go ahead and find the value of GE at 2000 km. So if we look at R equals 2000, and we draw a line up to GE, and then remembering that GE is described on the right side, if we, sorry, I was too low. GE is approximately about 7. Okay. But it said that the value of GE is less at that location. Now, less and more, those two words are really important to note. Less and more indicate a comparison, which means we need to compare this value 7GE to something else. The question then becomes, what is that something else? We can find that something else either by peeking at the question or at the answer choices. Now, if we look at either case, if we look at the question, we see that another R is mentioned other than 2000 km, and that's 4000 km. And we see it here in the question, and we see it in the next answer choice. So we can expect that we are going to be comparing the GE at 4000. So if we go to 4000, go that dotted line, and we go across, we see that the G at 4000 is 10. So is 7 less than 10? Yes, it is. So the GE at 2000 is less at that location compared to the one at 4000. So we know that's factually true. Now, does that indicate that there is a smaller gravitational force exerted on it? Who knows? But we know that this piece is true, which means we cannot eliminate A for now. Okay? Let's continue our analysis. Let's go to B. Okay? We see the rock located at 4000 km. The value of P is less at that location. All right, well, let's check out the P at 4000. Well, P is noted by the solid line. And if we draw a line to the left, we see the P at 4000 is approximately 5. And the P at 2000 is approximately about 11 or 12. The P is less at 4000. Yes, that is true. Okay. So it has a smaller mass. Again, I don't know. Let's just leave that as is. Let's look at C. Neither rock. The rocks have identical masses. So they have the same weight. Maybe. We don't know if they have identical masses. D. Neither rock. The value of G is the same for both rocks. Clearly, this is not true. So again, we don't know the question, but GE is definitely not the same in both rocks. So now let's consider the question. Going to 19. We consider two hypothetical 1 kg rocks. Kg is a measure of mass. All right. Based on figure 1, which of these two rocks, if either, is more likely to weigh less? Now, this is a question where having a little bit more science knowledge will help you out here. Weight is measured, if I can actually type in weight is equal to mass times gravity. Okay, so if we understand that principle, mass times gravity, let's take a look at A. The value of GE is less. Okay, so what does GE stand for? We go up to top. GE stands for the gravitational field. So does a lower gravitational field imply lower gravity? Probably. I'm leaning toward this value here. Okay? So lower gravitational force does indeed equate to a lower weight. So let's lean toward A. Well, what does B say? B is about this P value, but P doesn't talk about gravity. Okay? In fact, P is a measure of mass, but both of these rocks have the same mass because both of them are 1 kg. So it's not going to be B. Now, C, it is true the rocks have identical masses, but remember, we have to consider gravity here. And C does not consider gravity. And we get the sense that the gravity will be different for the rocks, so we don't expect both rocks to weigh the same. So, with a little bit of background, we could say that 19A would be the correct answer. Let's go down to the answers and see what come up. Well, here are the science answers. If we go down to 14 to 19 down here, we see we get 14H, 15A, 16J, 17C, 18F, and 19A. we did get all of the same answers. So what do I hope you get out of this ACT section? I hope you understand that the answers can be logically deduced if you follow the charts and really pay attention to the axes. And knowing what values to compare. Now, not all passages are going to be structured like this. This is what we call a data passage, where the focus is on charts. Sometimes you're going to see passages which have different studies, but they're going to follow similar principles. There are going to be questions that will direct you to figures and charts and tables. You're going to want to follow the axes on figures and titles on tables. You're going to need to compare values. You will want to pay attention to keys so that you really point to what is represented. And occasionally, you're going to need to read these paragraphs, and you really often only need to read these paragraphs for the latter questions to get a little bit more understanding of what these letters could stand for. Okay? So hopefully you got a better understanding of ACT science. Thank you so much for watching. If you like what you saw, please click the thumbs up button. And if you want to see more of my videos, or you want to ask me a question on one of my office hours live streams, please click subscribe to Sophos Tutor.